Hi, Algebra 1. Welcome to factoring trinomials when a is greater than 1. We're going to run through the steps, and then we're going to try some problems together. So step number 1 is the same as it was before. We're going to factor out the greatest common factor, or the GCF, if there is one. Obviously, if there isn't one, then we're going to jump right to step 2, which is find the factors of ax squared. Okay, so we'll essentially be breaking up this first term, like for example in number 1, we'll be breaking up the 2x squared, or in number 2, we'll be breaking up the 12x squared. We then want to break up and find the factors of c, or the constant. So in example 1, -3, and in example 2, -6. Okay, we then are going to do the method called guess and check. And so we are going to guess and check until we find the right combination of factors whose sum is b, or the middle term. And then we would check our answers by multiplying the factors together. Oops. I'm going to make that box a little bit bigger, and then we're good to go. Okay, so on my scratch paper, I already have my problems written out. So let's give them a shot and let's see how it goes. So I am going to do this a little bit differently than I did when a was equal to 1. When I start listing out my factors, I'm not going to pay attention to the signs a lot until we get to the guess and check part. So you'll see what I mean in just one moment. So we're going to start by looking for a GCF. So we've got 2x squared minus 5x minus 3 in example 1. So 2, 5, and 3 are all prime numbers. So there is no GCF that I can factor out because there's also no variable that they all have in common. So I'm going to jump right to step 2, which is breaking up ax squared. And the only way to break up 2x squared is 2x times x. And here's where it's going to be a little bit different. I'm going to ignore the sign for right now, and I'm just going to focus on the 3, and the 3 is prime, right? That only breaks into 1 times 3. So I'm going to set up my two binomials, my two sets of parentheses, and pop 2x in the first one and an x in the second one. So now here's where the guess and check part comes into play. I have to figure out, do I need 1 and then 3, or do I need 3 and then 1? And then I also have to figure out where the negatives and the positives go. So I'm going to keep my factors in the order that they already are. So I'm going to put a 1 here and a 3 here. And I know that one of them has to be negative and one of them has to be positive. Okay, because that's the only way we're going to get a -3. So I know that I either need 2x plus 1 or I need 2x minus 1. I need x plus 3 or I need x minus 3. I just have to figure out which one is which. And the way that I figure that out is by doing something called, or what I'm going to refer to as checking the outer and the inner. So what I mean by the outer and the inner is I'm going to check this 2x and the 3, and I'm going to check the 1 and the x. I'm literally going to multiply them together. So when I check that outer, that's 2x and a 3. That's going to give us 6x. And then on the inside, that's 1 times x, and that's going to give us a 1x. Okay? So when I have two different terms like this, the bigger term, the 1x or the 6x, will get the exact same sign as the term in the middle. So when I look at the middle is a -5x. So that means I'm going to make it a -6x plus 1x, because -6 plus 1 gives us a -5. So then I'm just going to follow my arcs. So that means I need 2x times a -3 and a +1 times x. Okay, so now I'm going to check my answer by multiplying it out, and we're going to see if this is the correct factorization. So 2x times x gets us 2x squared. 2x times -3 gets us a -6x. 1 times x gets us a +1x. And then 1 times -3 gets us a -3x, which that does clean up to 2x squared minus 5x minus 3, which is exactly what we started with. And so this is the correct factorization. 2x plus 1 times x minus 3. Okay, so that might have been a little bit confusing. Let's try it again. Okay, factoring is a skill, so the more we do it, the better we get at it. Okay, so let's take a look at number 2, 12x squared plus x minus 6. So again, I look for a GCF. That's always step 1. 12x squared plus x minus 6. They don't have a variable in common, and they don't have a number bigger than 1 in common, so there is no GCF. So I'm going to jump right to breaking these up. So we've got 1x times 12x. We've got 2x times 6x. And we've got 3x times 4x. In the back, with the 6, we've got 1 times 6, or we've got 2 times 3. Okay, so when we have choices like this, where there's more than one pair, we're always going to pick the pairs that are closest together. So when I look at my 12x squared, I'm going to start with the 3x and the 4x because on a number line, 3 and 4 are closer together. If the 3x and the 4x end up not working, then I'll move to the 2x and the 6x. And then if they don't work, I'll move to the 1x and the 12x. Okay, when I look at the 6, I'm going to try 2 and 3 because again, on the number line, they're closer together than 1 and 6 are. So my first pairs that I'm going to try are the 3x and the 4x in combination with the 2 and the 3. Okay, so let's give it a shot and let's see how we do. So let's do 3 and 2. And immediately, I know this is wrong. This is definitely not going to work because I see that these have a 3 in common and these have a 2 in common. So if this were correct, that means that the original problem would have a GCF. So when I start to guess and check, when I start to put in my numbers, I want to make sure that I look for a GCF first, because if there isn't a GCF, then the factors or the terms that are inside the sets of parentheses that are inside our binomials will not have anything in common. So I'm actually going to change my mind right away, and I'm going to flip-flop the 2 and the 3. So I'm going to put the 2 here and the 3 here. And then again, I'm going to check my outer and my inner. So let's check our inner. That gets us an 8x. Okay, and then I'm going to check my outer, which that gets us a 9x. Okay, so again, I compare 8x and 9x. 9x is bigger, and so 9x gets the sign of the term in the middle. So that'll be plus. So when I follow my arcs, that means this needs to be a positive 3, and that 8 is going to become the minus because I have a negative 6 at the end. So I know I need either positive 2 times negative 3, or I need a negative 2 times a positive 3. And in this case, I needed the negative 2 and the positive 3. Okay, so let's multiply this out and let's see if we did it right. So 3x times 4x gives us 12x squared. Okay, 3x times 3 gives us 9x. Negative 2 times 4x gives us a minus 8x. And then negative 2 times 3 gives us a negative 6. And when we add 9x and negative 8x, or 9x minus 8x, we do get a positive 1x. So 3x minus 2 times 4x plus 3 is the correct factorization. Okay, so the factorization of every trinomial and every polynomial is unique, meaning there's only one correct answer. The only other way that we could write this answer would be if we had 4x plus 3 times 3x minus 2. But notice the 4x plus 3, like that factor itself, that set of parentheses, that binomial did not change. I just flip-flopped the order, okay? So we've got 4 more. Let's give it a shot and let's see how it goes. Okay, so in question number 3, 18x squared minus 17x minus 15. Do we have a GCF? Great. We don't have a GCF in this problem. So we're going to go right to breaking it up. So 18x squared breaks into 1x times 18x, 2x times 9x, or 3x times 6x. Okay, 15, we've got 1 times 15, and we've got 3 times 5. I know, again, because the 15 is negative, that I need one of those to be positive and one of those to be negative. So we're going to start with the ones that are closest together. So I'm going to start with a 3x in the first set of parentheses and a 6x in the second set of parentheses. And then I'm going to start with a 3 and a 5. And immediately, I know this isn't going to work because we said there was no GCF, but 3x and 3 have a 3 in common. So we're going to erase real quick. And I'm going to flip-flop. Okay, so I'm going to put the 5 in the first set of parentheses and the 3 in the second set of parentheses. Oh, wait, this also isn't going to work because 6x and 3x have a common factor of 3. So either way we try this, this isn't going to work. So I need to change what I'm trying. So instead of the 3x and the 6x, instead of switching the back like we did in question 2, let's switch the front and let's see what happens. So instead of 3x and 6x, I'm going to try the 2x and the 9x. Okay, so 9 and 3 have a common factor, so I'm actually going to put the 9x over here and the 2x over here. That way, the 9x and the 3 aren't in the same set of parentheses. Okay, so now 9x and 5 don't have anything in common. 2x and 3 don't have anything in common. So let's give it a shot. Let's see how we do. So the outer, that's going to get us a nice 27x. And the inner, that's going to get us a 10x. Okay, so one of these has to be negative and one of these has to be positive. And the larger factor will always take the sign of the middle term. So that means the 27 is going to be negative and the 10 is going to be positive. So then I just follow my arcs. So that means that the 9x times 3, that has to be negative. So we're going to make the 3 negative. And the 5 times 2x needs to give us a positive 10x. So that means we need a plus 5. So number 3 factors into 9x plus 5 times 2x minus 3. Okay, question number 4. Negative 12x squared minus 2x plus 24. Do we have a GCF in example 4? Great. And we want to remember that when the leading coefficient is negative, we must factor out a negative. So our GCF for problem number 4 is a negative 2. And that's going to leave us with positive 6x squared plus x minus 12. So now that we've got that GCF, we want to make sure that we bring the GCF with us everywhere. And so now I'm just focusing in on the smaller, simpler 6x squared plus x minus 12, right? 6 has fewer factors than 12. 12 has fewer factors than 24. So by pulling out the GCF, we made the problem easier, which is always our goal. So 6x squared breaks into x times 6x or 2x times 3x. In the back, we've got 1 times 12, 2 times 6, or 3 times 4. So I'm going to start by bringing down my GCF, and then I'm going to set up my 2 sets of parentheses, and I'm going to try the factors that are closest together on the number line. So which pairs do we want to try first? Good, we want to try the 2x and the 3x. And then what about for the 12? Great, we want to try the 3 and the 4. So again, I want to be super careful. I don't want to put the 3 in the second set of parentheses because there's already a 3 there. So I want to put the 3 in the first set of parentheses and the 4 in the second set of parentheses. So I want to make sure that the terms inside the binomial or inside the set of parentheses don't have any factors in common. So now we're going to check our inner, which that guy is going to give us a 9x. And we want to check our outer, which 2x times 4, that guy is going to give us an 8x. So of the two, 9x and 8x, 9 is the bigger factor. So that's going to take the sign of the middle term. So that's going to be plus. So when I follow that arc, that means that we want a positive 3 times a positive 3x. And that means the 8 is going to be negative. And that gives us a 2x times a negative 4. And if we were to check this, I would multiply the two sets of parentheses first, and then I would distribute the negative 2. But this is the correct answer for example number 4. All right, kiddos, 2 more. Okay, so let's take a look at number 5. Do we have a GCF in number 5? Great. What is it? Great. It's x. So we're going to pull out that x, and that leaves us with 3x squared plus 16x plus 5. This one's a pretty easy problem because 3x squared has to break into 3x times x, or x times 3x, and 5 has to break into 5 and 1, or 1 and 5. Okay, so I'm going to bring down my GCF, write that down first, and then I'm going to put 3x in one set of parentheses and x in the other. So when I think about this, I'm trying to get to a middle term of 16. This is also the first time that our C value has been positive. So when the C value is positive, like this guy is, that means we want the signs to be the same. Okay? When the middle term is positive, that means both signs are going to be positive. So that's going to give us a 3x plus something and an x plus something. When I think about this outer, who do I actually want to multiply 3 by? 1 or 5? Okay, we're going to multiply by 5 because that's going to make it closer to that 16 because 3x times 5 gives us a 15x. Okay, so then when I think about the inner, right, we're going to use the other factor, which is 1, and that gives us a 1x. So 15x plus 1x, it gives us a 16x, and so this is the correct factorization of 3x cubed plus 16x squared plus 5x. All right, kiddos, our very last problem. Number 6, do we have a GCF in number 6? Of course we do, especially because the leading coefficient is negative. So they all have an x in common and they all have a negative 4 in common. So our GCF is a negative 4x. When I pull that out, we are left with 2x squared minus x minus 6. Okay, so also fantastic, great, wonderful. Our leading coefficient on the inside of that trinomial is now a 2, and that's a prime number. So I'm going to bring down my negative 4x. I'm going to bring down my GCF, and the only way to break up 2x squared is 2x and x. Right? So we have a negative 6 on the end, so we've got a couple choices here. We can do 1 times 6, or we can do 2 times 3. Again, 2 and 3 are closer together on the number line than 1 and 6, so that's the pair that I'm going to use. But when I pop them in, I don't want to put the 2 in the first set of parentheses because that means 2x and 2 would have a common factor. So I'm going to put the 3 here and the 2 here. Okay, so now we're going to check our outer and our inner. So our inner gets us 3x. Okay, and our outer gets us a 4x. Okay, so again, one has to be negative and one has to be positive because of the negative 6. And 4x is larger than 3x, so 4x is going to be negative. So we follow that, and that's going to give us 2x times negative 2. And then to get a positive 3x, we want that to be a positive 3. And the answer for number 6 is negative 4 times 2x plus 3 times x minus 2. Okay, kiddos, that concludes our lesson on when a is greater than 1 using the guess and check method. If you have any questions, don't forget to set up an appointment with your teacher. Good luck!